Good afternoon, class. We are looking at chapter 3, derivatives. Here's section 3.2, the derivatives as a function. So we looked at section 3.1, derivatives and rates of change, tangents, and now we're going to look at the derivatives as a function, which in short, f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0 by definition. So what did we cover? Let's just quickly recap. When you have 2 points, you can calculate the average rate of change, rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. There are various formats of the same thing. And the line that has 2 points on a curve is known as a secant line. As Q gets closer and closer to P, gives rise to the tangent line. Therefore, we define the tangent line as the limiting position of secant line PQ as Q approaches P. And so we go with the concept known as the instantaneous rate of change. So there are 2 definitions, f prime of a or m equals limit of f of x minus f of a over x minus a as x approaches a, or the limit of f of a plus h minus f of a over h as h approaches 0. Then I reminded you about various formats of the lines, standard form, point slope, and slope intercept. If we use this point with coordinates a comma f of a and put it into point slope format, y minus y1, that means y minus f of a equals m times x minus x of 1 or a, where m is f prime of a. However, instead of memorizing that, just stick with the point slope format and you don't have to memorize anything. Now, 3.2, the derivative as a function. We have considered the derivative of a function at a fixed number a. Everybody remembers that? F prime of a is the limit of f of x minus f of a over x minus a as x approaches a. Or the limit of f of a plus h minus f of a over h as h approaches 0. Now, here we change our point of view and let the number a vary. If we replace a in equation 1, in this equation, by a variable x, we obtain the following. F prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. If you recall, the last question in the previous section, I kept the a as a instead of changing it with a number, and then it gave me an opportunity to change the a to any number I want. In essence, that's the same concept. If you go with this formula, x will work. If you want to go with this and keep it as a, just don't change the a to a number, and then when you're done, change the a to x. It works out in the same manner. Other notations, given y equals f of x, then some common alternative notations for the derivative are as follows. F prime of x equals y prime dy dx, df dx, d dx of f of x, capital D of f of x, d sub x of f of x. The symbols capital D and d dx are called differentiation operators because they indicate the operation of differentiation, which is the process of calculating a derivative. We can rewrite the definition of a derivative in Leibniz's notation in the following form. dy dx is the limit of delta y over delta x as delta x approaches 0. A function is differentiable at a if f prime of a exists. It is differentiable in an open interval, any of these formats, if it's differentiable at every number, every point in that interval. Let's look at an example. We have seen these types of questions, finding an equation of a tangent line to the graph of the function. In this case, the function f of x squared of 3x plus 1, and the point is x equals 8. So in order to find the equation of any line, first we need a pair, x equals 8 when we plug in here. We get 3 times 8. 24 plus 1 is 25. So the pair would be 8 and square root of 25, which makes it 5. So we have the pair. We also need the slope. According to the previous section, we would calculate f prime of 8. We can do so, however, for this section, we're going to calculate f prime of x, a general form, and then we plug in 8, and it becomes the slope. The advantage of that is that if we were interested in finding the slope, the equation of a tangent line at several points, then it would make it easier. According to this definition, the limit of f of x plus h minus f of x over h as h approaches 0. So that would be the limit of the square root of 3 times x plus h plus 1 minus the square root of 3x plus 1 over h as h approaches 0. Bear in mind, we are using the definition. As of the next section, we are going to use rules that are going to be faster and easier. But for now, definition as we did in the previous section. So if you plug in, you notice you get 0 over 0. Because you're dealing with the square root, you are going to multiply by the conjugate of the numerator and divide by it. Conjugate means change this to a plus sign. And this is a minus b, a plus b. The result is a squared minus b squared. So you square this one minus you square this one. In other words, we get the following. The square root of 3 times x plus h plus 1 quantity squared minus the square root of 3x plus 1 quantity squared, and each one comes out. And all you have to do your algebraic techniques to finish the job by distributing here. You get 3x plus 3h plus 1 minus 3x minus 1. 3x and minus 3x cancel each other. Positive 1 and negative 1 cancel each other. So the numerator is left with 3h. Remember, as h approaches 0, the 0 in the denominator creates a problem. You're hoping to get rid of the h, and it happens here. And now, if I apply h equal to 0, this becomes square root of 3x plus 1, which is identical to this piece. And therefore, f prime of x becomes 3 over 2 of this, 2 square root of 3x plus 1. So we want to find an equation of a tangent line. We already have the pair. Now we need the slope, which is f prime of 8. So if I plug in 8, remember when we plugged in 8, this became 5. So this is 5. 3 over 2 times 5, or 3 over 10. F prime of 8 is 3 over 10. And now elementary algebra, y minus y1 equals m times x minus x of 1. Y minus 5 equals m 3 over 10 x minus 8. If we distribute, this becomes 3 over 10 times x. This becomes negative 24 over 10, or negative 12 over 5. When we move, negative 5 becomes positive 5, or 25 over 5. Minus 12 over 5 gives us 13 over 5. Therefore, the equation of a tangent line, is y equals 3 over 10 times x plus 13 over 5. If you plug in this pair, it works, and it just says that this process was done right. It doesn't say anything about f prime of x, even the slope. We will look at more examples later on. For now, let's switch gears, and here's example 2. The graph of a function f is given in the figure. Use it to sketch the graph of the derivative f prime. And to do so, I want to remind you of what happens in peaks and valleys, the local extrema, max and mean. If you were to draw a tangent line, would be a horizontal tangent line, which means the slope is 0, so f prime is 0. So there are some pieces of information. Relative extrema, relative max and mean, f prime is 0 over here, and over here. When f prime is positive, f is increasing. When it's negative, it's decreasing. To give you an idea, for example, if you look at this portion of the graph, and it's not a line, you assume it's a line, looks like a line with a positive slope. So first thing first is 3 points, A, B, C, correspond to 0. I'm going to discuss this in a moment. But what does it mean? That means if I were to graph the f prime of x, sketch the graph, a rough sketch. For the same x coordinate at this point, the y coordinate would be 0. For the same x coordinate for B, the y coordinate would be 0. For the same x coordinate for C, the y coordinate would be 0. And now, let me explain this point too. What they did, they picked up a pair. They did their best to draw a tangent line. They picked up 2 pairs, 2 points, and they have calculated this slope, and that's why they put the slope is almost 3/2. This will correspond to the same x coordinate 5 with the y coordinate equal to the slope 4 f prime. Now, this portion of a graph decreasing, decreasing. This portion of a graph increasing, increasing. So take a look at what happens. Those portions are decreasing. Those portions are increasing. Now, corresponding to A, we have A prime, which is 0. Corresponding to B, we have B prime, which is 0. Corresponding to C, we have C prime, which is 0. So this is decreasing class. That means f prime is 0. That means must be below the x-axis. So this part below the x-axis, something like that, okay? But this portion is above the x-axis. This portion is what? F prime is positive, so it's above the x-axis, but has to come back down to B prime. Why is that? Because this is positive. At A is 0, at B becomes 0, so it has to come back down. Now this is decreasing again. This portion is decreasing again, class. So it goes below the x-axis, but it has to come back up to 0. Again, why would that be? Because at B corresponds to 0, at C corresponds to 0, so it has to come back up. And then it's increasing, so it moves up for this portion, looking like that. And this is a more precise graph. Let me clean up the mess and pay attention again. A corresponds to A prime 0, B corresponds to B prime 0, and C corresponds to C prime 0. And this pair 5 comma 3/2 or 5 comma 1.5. To the left of A, decreasing below the x-axis. Between A and B, increasing, so above the x-axis comes back to 0. Between B and C, decreasing below the x-axis. The reason it comes back to 0 at this point, and then increasing above the x-axis. a rough sketch. So for example, in this case, example 3, the graph of a function f is given. Use it to sketch the graph of the derivative f prime. For the first case, we are dealing with a line, the easiest one. You remember, when you want to graph the derivative of a line, just calculate the slope, and y equals the slope is the answer. So all you have to do, use rise over run, pick a couple of pairs. Clearly, this is 0, 0. And this one, class, is 1, 3. Please understand the scale along the x-axis and the y-axis doesn't have to be the same. This is 1, but this is 6, so makes this one 3. So 3 minus 0 over 1 minus 0, m is 3. Whatever the value of m is 3, y equals 3. M is 5, y equals 5. M is 10 or negative 10, y equals negative 10. So in this case, the line y equals 3, as you know, it's a horizontal line. There you have it, and it's done. Let's look at this function. First, the easy points. This point. This point. Those 2 points have derivative which is 0 because it's a horizontal tangent line. So they correspond to these 2 points. And this portion of the graph is decreasing. This portion of the graph, both of them, this side and this side, increasing. So if we were to graph this roughly, this one is increasing, class. This is increasing. So all the way to this point, so it's above the x-axis. This is increasing above the x-axis. This is decreasing below the x-axis, and it comes back up. I want to make sure we understand what's happening. To the left of this point is increasing above the x-axis. To the right of this point, increasing above the x-axis. In between is decreasing, that goes below the x-axis. However, at this point is 0, so it's this point. So when it goes down, it has to come back up. And the graph looks like this, which is much better now. And I'm going to erase mine. In this case, again, this point is an important point because we can clearly see that at that point, we should have a 0. It happened to become 0, 0. This portion is increasing, so above the x-axis for this portion. This is decreasing, so below the x-axis, and it looks like this. Again, let me erase mine. So at this point, to the left of it is increasing, so above the x-axis. This point to the right of it is decreasing below the x-axis. How can a function fail to be differentiable? There are 3 ways. When we have a sharp corner, when we have a discontinuity, when we have a vertical tangent line. A corner or kink, the graph of f has no tangent line. At this point, the left and right limits are different. How do you draw a tangent line? That's why it fails. If f is not continuous at a, then f is not differentiable at a. So at any discontinuity, for instance, a jump discontinuity, f fails to be differentiable. When there's a discontinuity, the function can't be differentiable. The limit of the absolute value of f prime of x as x approaches a is infinity. The graph of a function f of x has a vertical tangent line at the point a comma f of a if and only if the limit of f prime of x as x approaches a is negative infinity, or the limit of f prime of x as x approaches a is positive infinity. Both sides have the same results. In other words, if you recall from elementary algebra, a vertical line, we said the slope is undefined. And what we really meant was that the slope was either infinity or negative infinity. And that's exactly what this one says. Both sides, they result in the same. However, we also have something called a cusp, at which point the left and right side have different answers. One side is infinity, one side is negative infinity. So when the graph of the function becomes vertical and then virtually doubles back on itself, such pattern signals the presence of what is known as a vertical cusp. In general, we say that the graph of f of x has a vertical cusp at a comma f of a, if and only if, this is how it's read, iff is read if and only if, the limit of f prime of x as x approaches a from the right is infinity, and the limit of f prime of x as x approaches a from the left is minus infinity, or vice versa. Both sides do not have the same result. One side has infinity as the answer, one side has the negative infinity as the answer. So for example, here at 0, the limit of f prime of x as x approaches 0 from the right is infinity, but from the left is minus infinity. And understand sometimes it becomes difficult to distinguish among those three. You don't have to worry about that too much. Here's a very simple example. The graph of a function f is given, where and why the function is not differentiable. Clearly, at x equals 0, because there's a discontinuity. Also, at 3, we have a vertical tangent line. I'll explain this further in a moment. For b, clearly at -1, we have a discontinuity. And at 2, we have a sharp corner. Now, how do we distinguish between a sharp corner and a vertical tangent line? I want you to notice over here, you have a V shape. So if it looks like a V shape or upside down V shape, that's a sharp corner. But over here, clearly it's not a V shape. It's going up, and therefore we are looking at a vertical tangent line. The graph of a function f is given. Use it to sketch the graph of the derivative f prime. Notice we have 1, 2, 3, 4 line segments. So for each line, we need to calculate the slope. So I'm going to throw in some numbers, and normally the graphs are such that you can read them. But in case you can't, here's the given points. You can calculate the slope for each line or line segment. So let's start calculating it for this one. So 0 minus 1 over -1 minus -3 results in the slope of -1/2. Because this has a slope of -1/2, clearly you should see that this one is positive 1/2. Minus 1, 0, 0, 1, you can clearly calculate the slope as 1, and over here as -1. So let's stick with the first one. Never mind the rest of it. If you look at this one, and if it was a line, not a line segment or half line, then all we had to do, look at the slope and say, you know what? We have to graph the horizontal line y equals -1/2, we would be done. I'm looking at the first part only. However, it stops here. And what happens here? You have a sharp corner. So it stops here. So take a look. This line segment gives rise to y equals negative 1/2. And again, we don't know if it continues or it stops here, so it doesn't matter. But for sure, we know there is a sharp corner here, so there is a hole there. It's not differentiable. And you continue with the rest of them. So what about the rest of them? This one, y equals 1. This one, y equals negative 1. This one, y equals 1/2. So for y equals 1, this would be a line y equals 1 like that. However, it stops here and here because we have a sharp corner here. So we have a hole here, and we have a sharp corner here. So we get this one. For the next piece, we also have a sharp corner here. We get this one. And for the last piece, the sharp corner here. So here's the synopsis of what happened. First, we calculated the slope. The slope for the first piece was y equals negative 1/2. So for this one, this would be this line. And the reason we stop here because the line stops here. And the reason we put a hole because there is a sharp corner. For this one, y equals 1. And we stop here and here because the line is just a line segment. Same thing here, it's a line segment. And both of them have holes at the end points because of the sharp corners. And the last piece, sharp corner results in a hole, and this results in y equals 1/2. We are going to find the derivative of the function using the definition. Again, please bear in mind, we do this pretty fast in the next section when we use rules. But for this one, for example, f prime of x is the limit as h approaches 0. F of x plus h makes it 5 times x plus h plus 1 minus f of x itself over h as h approaches 0. So all you have to do is simplify this fraction and you get to the answer. Distribute, you get 5x plus 5h plus 1 minus 5x minus 1. 5x and minus 5x cancel each other. 1 and negative 1 cancel each other. So you're left with 5h. The h drops from the top and the bottom. The limit of 5 as h approaches 0 is 5. For part B, f of x equals 2 over x, so we're going to put it into this definition formula. The limit as h approaches 0, f of x plus h makes it 2 over x plus h, minus f of x is itself over h as h approaches 0. So we are dealing with a complex fraction. And the technique is LCD, because if you plug in, you get 0 over 0. The LCD is the product of the two denominators, x times x plus h. You have to multiply and divide by it because this expression must be 1, and now it is. The denominator, you don't touch it because h approaching the 0 makes the denominator 0. That's why you're hoping to get rid of it. What about the numerator? When you multiply this LCD by the first fraction, you get 2 times x. When you multiply it by the second fraction, you get minus 2 times x plus h. And again, notice the denominator, we keep it as a product. We distribute the negative 2, we get 2x minus 2x minus 2h. These two cancel each other. So the numerator is only negative 2h. The h here and there, they cancel each other. So f prime of x becomes the limit as h approaches 0 of minus 2 over x times x plus h. And if we apply the 0 here, this becomes x, with this x becomes x squared. The final answer is negative 2 over x squared. All right, class. So let's put this into the definition, the limit of f of x plus h minus f of x over h as h approaches 0, which simply put makes it the limit of 7 times x plus h quantity squared plus 4 minus the same thing, 7x squared plus 4 over h as h approaches 0. X plus h quantity squared is x squared plus 2xh plus h squared. Distribute number 7, we get 7x squared plus 14xh plus 7h squared plus 4 minus 7x squared minus 4. All we have to do is simplify. This is all algebraic techniques, class. Simplify the numerator as follows. 7x squared and minus 7x squared cancel each other. 4 and negative 4 cancel each other. And we can factor this out. We can factor out the 7h, but we just want to get rid of the h. So I'm going to take out the h only. Again, the proper way of factoring, 7h comes out. And you get 2x plus h. But we want to get rid of the h. That's why I took out the h only. And now if you apply h equals 0 here, you get 14x. So f of x equals 7x squared plus 4. F prime of x is 14x.